There are two databases, one for navigation information and the other for performance information. The navigation database contains the position and, where required, the elevation and frequency of navigation aids, airports and runways. It also contains the operator's route structure, airways, waypoints, SIDs, stars and approach procedures. This information is subject to constant update, so the period of validity of any set of data is 28 days only. A new set is issued by the company supplying the data and is loaded into the flight management computer, usually from a form of compact disk. This can only be done by the maintenance personnel. Pilots cannot access the permanent navigation database. Two sets of navigation data must be carried, one for the current 28-day period and one for the following one. The 28-day period of validity is called an AIRAC cycle. Unless two sets of AIRAC cycle data are present and one of them is current, the FMS will not continue with its startup sequence. There are also two other navigation databases, the supplemental and the temporary. If the pilots need to use some information not in the permanent database, such as unpublished waypoint, they can insert it into the supplemental or temporary nav database through the CDU. Supplemental data is stored indefinitely unless removed by the crew. The temporary nav database is erased automatically on shutdown. There is also a performance database. This contains information on climb and cruise performance, thrust limits, maximum and minimum altitudes for various configurations, drag characteristics, and expected fuel flow. Maintenance personnel can refine this data by entry of correction factors for individual aircraft's drag and fuel flow characteristics, which are established from the aircraft's history. We said earlier that an FMS may be structured to have either one flight management computer or two. On those systems that have two, there are reversionary modes. Here is the system in its normal configuration. This is called dual mode. Each flight management computer produces independent calculations. The outputs are compared and checked for agreement. Minor differences are synchronized to one nominated FMC, usually the captain's. This results in both pilots' CDU displays being identical. However, if the cross-check shows a discrepancy above a predetermined value, the system changes to independent mode. This happens automatically in some systems and is selected by the crew in others. The synchronizing link between the two systems is broken. Now we have independent calculation and independent output. The pilot's displays may now conflict, and, if they do, it is up to the crew to choose which is the most likely to be correct. Finally, we may get a failure of one computer. In this case, the remaining one takes over both displays. This is called single mode. It is specifically a failure mode in which one FMC feeds both displays. Both pilots' displays will be identical. Let's summarize this lesson. The flight management system is designed to provide continuous automatic navigation, guidance and performance management. They vary from type to type, but they all contain a flight management computer, a control and display unit, 2 or possibly 3 inertial reference systems, an air data computer, radio navigation inputs, navigation and performance databases, and inputs of engine and fuel data. They simultaneously compute lateral navigation, or LNAV, and vertical navigation, or VNAV. The control and display units, or CDUs, consist of a display and a keypad, and are used during pre-flight to manually initialize the IRS and FMC with dispatch information, flight plan routing, zero fuel weight, and planned cruise altitude. In flight, they are used to control the FMC and display flight information, and to show alert and advisory messages. The navigation database consists of 2 AIRAC cycles. Unless at least one is current, the system will not function. The pilots cannot alter the permanent nav database. However, they can enter information into the supplemental and temporary memories. The performance database consists of climb, cruise and descent speeds, power setting and fuel flows. On systems where there are 2 FMCs, the normal operating mode is called dual mode. If there is a mismatch of information, the system reverts to independent mode. And if one FMC fails, the remaining computer feeds both displays in single mode. That completes this lesson. The next one will deal with equipment operation.